Hi, myself Harshavardhan.m. I am from Sri Venkateshwara College of Engineering. Today I am going to discuss a topic on environmental engineering on vector calculus. So first, let me see about introduction to environmental engineering and vector calculus. Environmental engineering focuses on improving the natural environment through sustainable practices. Vector calculus provides essential mathematical tools for analyzing fluid flow, pollutant dispersion, and other environmental phenomena. Understanding vector calculus is crucial for solving complex environmental engineering problems. Next, we will see the role of vector fields in environmental engineering. Vector fields represent the distribution of quantities such as velocity and force across a region. In environmental engineering, vector fields help model wind patterns, water flow, and contaminant transport. Analyzing vector fields allows engineers to predict the impact of human activities on natural systems. Next, we will see about gradient divergence and curl. The gradient of a scalar field indicates the direction of steepest ascent, crucial for identifying pollution sources. Divergence measures the magnitude of a source or sink at a given point, helping assess air and water quality. Curl qualifies the rotation of a vector field, which is important in understanding turbulent flow in natural systems. And this part of side, the gradient of a scalar function indicates a vector field that represents the direction of the steepest descent, that is maximum decrease in a temperature field. Heat flows in the direction of maximum decrease of temperature if the temperature is given by the following scalar function: T of x comma y comma z is equal to yz square plus 3z square x plus 3z. So this is example for the given gradient divergence and curl. Next we will see the applications of gradient in environmental studies. Gradients are used to determine the direction and rate of contaminant movement in groundwater. Understanding temperature gradients helps in analyzing thermal pollution in water bodies. Engineers use gradient analysis to optimize the placement of remediation systems for contaminated sites. Next, we will see about divergence in pollution dispersion models. Divergence is critical in modeling how pollutants disperse through air and water systems. By applying divergence, engineers can estimate the concentration of pollutants over time. This information aids in designing effective mitigation strategies for environmental protection. And this part of side will give an idea for divergence in pollution dispersion models. Next, we will see the curl and fluid flow in natural systems. Curl analysis helps engineers understand the behavior of natural water bodies such as rivers and lakes. It can reveal patterns of circulation that affect sediment transport and nutrient distribution. Understanding these patterns is essential for managing aquatic ecosystems and water quality. Next, we will see about computational fluid dynamics in environmental engineering. Computational fluid dynamics, that is in short form we call it as CFD, utilizes vector calculus to simulate fluid flow in various environments. CFD models helps engineers visualize complex interactions between air, water, and pollutants. These simulations are vital for planning interventions in contaminated areas and designing sustainable systems. So next let we see the case studies in environmental vector calculus. Numerous case studies demonstrate the successful application of vector calculus in real-world environmental challenges. For instance, modeling the flow of oil spills using vector fields has improved response strategies. Other studies have focused on assessing the effect of urban development on local hydrology using divergence analysis. Next, we will see the challenges and future directions. Environmental engineers face challenges in accurately modeling complex systems due to variability in environmental factors. Advances in computational power open new avenues for more detailed and dynamic simulations. Future research may focus on integrating machine learning with vector calculus for enhanced predictive capabilities. So let me come to the last topic, that is conclusion. Vector calculus is a vital tool in the field of environmental engineering, facilitating better understanding and management of ecological systems. By applying vector calculus, the concepts engineers can optimize design and intervention strategies for environmental sustainability. Continued exploration in this area will lead to innovative solutions for pressing environmental issues. So, this was my presentation. This was my presentation about environmental engineering on vector calculus. Thank you.